Good morning, guys. Welcome to April 2nd Rhombus Proofs. Our due now today, the coordinates of the endpoints of AB are A, -6, -5, and B, 4, 0. Point P is on AB. Determine and state the coordinates of point P such that the ratio of AP to PB is 4:1. And I left you a hint there that says graph the line and use its slope to break the line up into 5 sections. So this was our lesson from a couple days ago where we divided up a segment into a certain ratio. So start with finding your slope of AB, which will be up 1, 2, 3, 4, 5, and then to the right 10. Make sure you simplify that slope. That's where we're going to use the simplified slope to break the segment up into a certain amount of sections, which will be 1/2. So up 1, right 2, make a point. Up 1, right 2, make a point. And keep on going with that. So you can see now that we did that, we have 1, 2, 3, 4, 5 sections, 5 pieces. And we want that ratio to be 4:1 for 5 total sections. Remember, with this, we're going to go left to right. We're going to go 4:1, 1, 2, 3, 4 sections left to right, and that leaves us 1 on the end. So that would be 4:1 ratio. So the point there we would be using is that point right there, because that breaks us up into a 4:1 ratio. Make sure you state the coordinates. Point P, that would be the point 2, -1. So coordinate, normal XY point, that would be your final answer. Alrighty, so your aim today, how do we prove quadrilaterals are rhombuses? Alright, on the coordinate grid. So there's your steps. Alright, you plot your triangle or your quadrilateral, find all your slopes, find all your distances, and write an explanation. To be more specific in terms of proving a quadrilateral is a rhombus, we're going to use the most basic rhombus property you could think of. Now, we have some more complex properties, like the diagonals intersect perpendicularly, the diagonals bisect the angles to which they're drawn, but this is just a day one rhombus property you learned about many, many years ago. We're going to show all 4 sides are congruent. Because that can definitely be accomplished on the coordinate grid. Remember what we did to show congruence, maybe the isosceles triangle day. We used the Pythagorean theorem. A squared plus b squared equals c squared. So we made a right triangle for every side length. We made a right triangle. And we used the Pythagorean theorem to solve, which I'll show you a couple examples of that. And then you'll try one on your own. Okay, so example 1. Quadrilateral ABCD has vertices A, -2, 3, B, 2, 6, C, 7, 6, and D, 3, 3. Prove this quadrilateral is a rhombus. So what we're going to do, we're going to show all 4 sides are congruent. For BC, the length of BC and the length of AD, those are very, very simple. You can just count the boxes because that's just a straight horizontal line. So count the units. For BC would be 1, 2, 3, 4, 5, and AD 1, 2, 3, 4, 5, a length of 5. Usually it won't be like that, but for example 1, not so bad. For the other side lengths, we also need them to be 5, right? All 4 sides congruent. But what we're going to do for AB and CD, we're going to make a right triangle out of that side length, where that side length AB now is the hypotenuse. Alright, so we have a right triangle. One of the side lengths is 3, another side length is 4, and AB is that unknown length there. So our setup would be 3 squared plus 4 squared is equal to AB squared. Okay, so we'll start simplifying. You might be noticing it's a Pythagorean triple. If you want to, you could just say your answer and then say that it's a 3, 4, 5 Pythagorean triple. Okay, but following through with actually showing the work, we would get AB squared is equal to 25, square root, both sides, and we get AB is equal to, is radical 25 equal to 5? Yes, it is. That's good. Okay, so we have 3 side lengths. Need one more. Make a right triangle out of CD. You're going to see the right triangle has the same dimensions as the blue one we just made. We have a length of 3 and 4 and an unknown length for CD. So once again, 3 squared plus 4 squared equals CD squared, and start simplifying. So it's good. 1, 2, 3, 4 equal side lengths. A conclusion statement. We did indeed show it's a rhombus because all 4 sides are congruent. Quadrilateral ABCD is a rhombus because all 4 sides are congruent. And we backed that up with coordinate geometry. On the grid, we found 4 lengths. They're all congruent. It has to be a rhombus. All right. We'll try another one together. Make sure, as always, you're sending me questions in Remind. You're doing your delta math. Okay. So quadrilateral NATS has coordinates n, -4, -3, A12, T81, and S3, -4. Prove this quadrilateral is a rhombus. The use of the set of axes below is optional. Remember, whenever it says that, you really should be using the set of axes. It's good to see the problem visually, and that's the way we've been doing things. So, we don't have any side lengths that are totally vertical or totally horizontal where we can just count. We can just count the boxes. We have to make a right triangle for all 4 side lengths and show all 4 sides are equal. So for example, NA, let's take a look at NA. Make a right triangle. Count your units. It'd be 1, 2, 3, 4, 5 here. And 1, 2, 3, 4, 5 here. So we'll set up the Pythagorean theorem to solve for NA, which would be 5 squared plus 5 squared is equal to NA squared. And we're simplifying. Now it's not a perfect square, so this is where you can just leave it as radical 50. So now, in order to make sure we did this, we follow through correctly here, we need all the other side lengths to be radical 50, or maybe we made a mistake. So another side length would be ST. You're going to see the sides, the dimensions of that right triangle we can make around ST. Those dimensions are the same. This is 5 and 5 again. So it's the exact same work, except instead of saying NA squared at the end, we'll say ST squared. And unfortunately, yes, you have to show the exact same work again with just a different side length. So it'd be 5 squared plus 5 squared is equal to ST squared. Okay, 2 equal side lengths, that's good. Now let's see what happens for AT and NS. Making a right triangle around AT, be careful, will look like so. Where those dimensions are a little weird here. It's This is 1, or side length of 1, and now going from up top, 1, 2, 3, 4, 5, 6, 7. Okay, it's a length of 7. So now you might be thinking, it's different dimensions, 1 and 7, so we're not going to end up with radical 50. It might be different. Well, let's check it with the Pythagorean theorem. 1 squared plus 7 squared is equal to the side length squared, what we're looking for, which is AT squared. So 1 squared is just 1. 7 squared, 49. That's equal to AT squared. AT squared is equal to 1 and 49 makes 50. That's good. All right, you can see we're going to end up with the exact same side length now. We get AT is also equal to radical 50. Good things. All right, one more side length. NS. Make a right triangle. The dimensions are just like the top one, 1 and 7 for that right triangle. So yes, we have to show the same work. 1 squared and 7 squared will give us NS squared. 1 and 49 again. And we get our fourth radical 50. By the way, radical 50 is just 7 point something that goes on forever. So you can visualize what, how long is that side length. All these side lengths on the grid, you can see a radical 50, which is, like I said, 7 point something. But it's good to see with different values here, you can still end up with 50, or radical 50 rather. Okay, so the explanation, this is all the coordinate geometry work you have to show. The mathematical work, the explanation is just as important. Okay, Nats, the quadrilateral, they said, is a rhombus because we showed all 4 sides are congruent. Okay. Now you're going to give example 3 a shot. Okay. This point here, I had to give you a different looking graph because this point here for C is 11, 13, so it would have fallen off the graph, but this one, all the points will fit. All right, so show all your work that gets you all 4 sides, Pythagorean theorem 4 times. You'll see that all of them are the exact same radical. Radical, I think, comes to 130, but show all the work that gets that. And write your explanation. Send me questions and remind. Your Delta Math is due tonight at 8 o'clock. Please make sure you're taking care of that. Have a wonderful rest of your day, and I'll see you mañana.